Arches are watercourse crossings that allow the natural streambed substrate and gradient to be maintained and can have minimal impact on fish when they are designed and installed using best management practices. Other key attributes of arches include that they do not restrict fish passage, have less long-term maintenance costs than bridges, and have easier site restoration than culverts. Certain types of arches can, however, be susceptible to scouring under their footings, and they do require an engineered design. Arches can be constructed from various types of materials, such as steel, high-density plastic, or precast concrete, and sit on footings. There are two main types of arches: footed arches and reinforced soil arches, also called GSRAs. Footed arches have a large concentration of weight on the arch structure, and this requires engineered footings to prevent scouring from occurring and to prevent the arch from sinking or slumping. Reinforced soil arches are designed to alleviate these concerns through the addition of geotextile layers within the fill material that disperse the concentration of weight and allow for a simpler footing design. This can make reinforced soil arches the more cost-effective option and can make them less prone to scouring. It's important to ensure the compaction levels within the structure meet the defined standards. Arch design is a key factor for success. When determining the proper size for an arch, both the width and length are important considerations. Arches should be wide enough to prevent constriction of the natural watercourse channel. Arches should be long enough to prevent road surface materials from entering the stream. Adequate arch length also decreases bank steepness and the potential for erosion. The length of the arch is limited by the site features. Head walls and end walls may be required to help hold back material. Key considerations: ensure the arch footings are suitable and that they are installed properly in order to prevent erosion under the structure or slumping. The footing should be placed on level, flat fills that will not erode, and that the footings are buried below the thalweg. In the case of reinforced soil arches, it's important to maintain quality control of the compaction to reach the desired strength of the structure. If an arch is replacing an existing culvert, the streambed must be restored to its natural grade before the arch is put in place. The new streambed under the arch should include a variety of particle sizes in order to mimic natural watercourse conditions. If prefabricated structures are being used, they should not be dragged into place, as this can cause erosion and sedimentation. Proper machinery should be used to lift the components as they are installed. Do not over-widen a channel when using an oversized arch, since this can reduce the water depth and impede fish passage. When adding the large angular material to create channel roughness inside the arch, it should not constrict or widen the natural watercourse, as this will alter the flow of water as well. Avoid introducing extra sediment into the watercourse. It's important to use clean, correctly sized fill that will not easily be moved by the force of the water. Best practices. When installing arches, it is important to reduce sedimentation as much as possible. One way to do this is to operate equipment from above the top of the watercourse bank. Another way to reduce sedimentation is to ensure the fill material around the arch structure is well compacted. There are key times to avoid when working in watercourses. These include adhering to the restricted activity periods for fish and ensuring that high flow conditions are not in effect while working in and around watercourses. It is important that there are no weak points in the foundation of the arch structure. One way to do this is to ensure that the footing designs are continuous. For example, concrete footings should span the entire length of the arch wall, instead of using intermittently placed concrete blocks that have spaces that can act as weak points where erosion is likely to occur. Structural stability is also influenced by the substrate under the footings. Footings should be placed on compacted gravel or a similar base that has a uniform support, and the footings must be buried beneath the thalweg. And as with all watercourse crossings, it's important to mimic the natural characteristics of the stream bed. This applies both within and at each end of the structure. Site reclamation. After installation, re-establishing vegetation is a top priority. This vegetation is key for intercepting sediment loads that can enter watercourses and to stabilize stream banks. Sediment from exposed soils and slumping of stream banks can have a significant negative impact on fish. All erosion and sediment control measures need to remain functional and on site until revegetation is adequately controlling erosion and runoff. Ensure that the side ditch and road water are not draining directly into the watercourse, as they can carry significant amounts of sediment, particularly during storm events. Stabilizing the area around the arch with bioengineering methods such as transplanted vegetation is ideal. Collect organic matter from the site while the structure is being installed. The upper layers of this organic material contain seeds and plant matter that will help revegetate the crossing in a natural and cost-effective way. If an arch needs to be removed from a site, the same erosion and fish protection measures should be applied. Return the stream bed to its natural state and ensure that no fill materials are left within the high water mark of the watercourse. Remove all non-biodegradable materials and revegetate any exposed soils. Monitoring and follow-up. Regular inspections are vital to the long-term success of watercourse crossing arches. Arch installations should be checked to ensure they are functioning according to their design and that there is no erosion or scouring occurring. Permanent marker stakes should be installed at each end of the arch to prevent damage from road maintenance equipment. Properly designed and installed arches can be a highly effective watercourse crossing. Regular inspections of the arches are vital to their long-term success and should occur before and after major storm events. When arches are installed on sites that do not contain groundwater seeps and are not prone to ice flows, their longevity can be increased.